triple integral, right? So before going to the triple integral, we have a small recap. So first we compare it single integral with the double integral, right? And there may be some functions as well. And here we used to have this thing, right? So this was representing the area under fx, right?
Yes, sir.
Yes. And this was representing the volume, right? Is it okay?
Yes, sir.
And
Yes, sir.
then we move us to this thing by saying that this integral, right? So this integral, if we take it in this way, let's say 1 dy dx, then it was what?
Area.
Area of region. So here we have chosen the region to be a rectangle, otherwise any generalized region will be there instead of xa, xb and yc, yd. We will have some area, right? And we want to say that if we replace that f of xy by 1, then obviously height will be 1, and then we'll get the area of the region, right? That's how we work, right? So now,
Yes, sir.
can you imagine that what will happen if I take, let's say, those limits, right? dz, dy, dx. Now, what this will represent? Can anybody tell me? If I take one only.
Sir, volume.
Yes.
Volume of the region.
So this, yes, this will be volume of the region. Region bounded by what? Bounded by XA, XB, YC, YD, ZD, ZF. But a complicated question will arise if what this will represent if I take a function over there. Let's say fxyz. Now, can anybody tell? Now here, as you see, this is a function with 3 variables, right?
Yes, sir.
3 variables as inputs. So I would say that these are 3 inputs, right? And 1 output. So function would be what? Yes, tell me, graph of the function will contain how many variables?
4.
4. Yeah. So can you plot that 4 variable function?
No, sir.
Not exactly, right? One way to explain this is hypervolume, right? And there is another way to explain it. So that we'll discuss. So let's say compare these two things. One is this one, right? One is this one, that means the area of the region. Another is this one, that means the volume. How they represent areas and volume. Earlier, we used to have this thing. We have a 2D region, right? So this is your 2D region. So that's what? A 2D region, right? And now we'll have a 3D region. So this will be our 3D region. Yes, you are with me?
Yes, sir.
Yes, sir.
Right? So let's say if you want to get the area, right? So what do you do in this? You simply, you simply subdivide this whole plate into the small rectangles, right? Yes, are you with me?
Yes, sir.
Now, keep in mind, I'm not plotting f of x, y, z. I'm only comparing the region for the double integral and region for the triple integral, right? So in double integral, we have two variables. That's why we have only two inputs. That's why our region will only lie in xy plane. Okay. So this is your x, this is your y, this is your z, and I'm only plotting the 2D region, right? For what? For double integrals. And here again, I'm only plotting the region, but this time for 3D, right? So this is your x, this is your y, this is your z. So this is our region, let's say. So for the for the sake of simplicity, I've only considered the cube, right? There may be some few another shapes, right? Okay. So how are you gonna do it? Now you will simply divide this region into what? Can anybody explain?
So cuboids.
So what we're gonna do? We'll subdivide this whole region into the small, I mean, very small, so that they also, look like a cuboids. So we'll, of course, we'll construct those pillars, right? And in this way and this way. And in this way also, right? This, and so on, right? So we'll keep on standing those pillars. And of course, we'll also slice through x-axis as well, from here as well, and from here as well. And these are also, these small cuboids are inside that big cube, right? Are you with me? Yes, tell me.
Yes, sir.
Is it okay? So I'm not only, not only taking the height, I'm also considering the small cubes over here as well, right? Let me use a different color so that you will come to understand. So like this, and this. And similarly, like here, here. Okay? Yes? So, so this big box contains so many small boxes, right? So this is what? This is again our region. Region for what? For triple integral, right? And as we have already decoded that this will represent a volume. Now, we know that this will represent a volume, but the point is, why to calculate volume using triple integral, right? Are you getting my stuff? Yes, tell me.
Yes, sir.
That,
Yes, sir.
see, my only point is, when we have double integral, we can calculate the volume using double integral. Then why we are using the triple integral, right? So this is the question we're going to answer that. But first of all, we'll do a few questions that how triple integrals are calculated, and after that we'll go through those things, that why why we use the triple integral in order to calculate the volume. So first of all, we'll do a few questions. And this is exercise 13.4.
Sir, switch to the previous page for just a second.
Yes, please.
All right, sir. All
So,
right.
so 1 second, please stay on this. Sir,
Yes.
can you explain this region for triple integral, that green part which you have drawn on the graph once again?
Which one?
Sir, जो ये green वाला बनाया है.
हाँ, मैंने ये बोला है कि अभी इसके ऊपर बॉक्सेस खड़े होंगे ना, जैसे ये, अगर मैं लेट्स से मैं ये कहना चाहता हूँ कि अगर जैसे ये पूरा बनाऊंगा मैं, ठीक है, एक पिलर बन जाएगा पूरा.
Yes, sir.
ठीक है, लेकिन ये पिलर ऐसा पिलर नहीं रहेगा, इसके अंदर भी ऐसे बॉक्सेस, ये छोटे छोटे बॉक्स होंगे एक्चुअली,
Fine, sir.
right?
Fine, sir.
That's what I'm saying. So this is one box. Okay,
Yes, sir.
this is another box. So this complete box, yeah, right, big box will contain so many means what? Actually infinitely many, right? Small boxes. Okay, so this is just for your understanding. Okay,
Fine, sir. Fine,
is
sir.
it fine?
Yes, sir.
So okay, let's move to the next thing. So what I'm saying is, why to calculate volume using the triple integral? That I'm going to answer. So first of all, we'll do few questions as I'm telling you, right? So now what happens? Let's say question number 9 on page number 1032. So simple question is, you just calculate this thing, 1 to e, 1 to e, 1 to e. All the limits are same, 1 upon x, y, z, and dx, dy, dz. So that you know that you, of course, you're gonna integrate with respect to x first. Okay. So the hierarchy is same. I mean, as far as computation part is considered, so you simply say that one more times you need to integrate. That's it, right? As far as computation is concerned. So we'll also go through that geometrical interpretation. But before going into that, what I'm saying is just try to calculate this integral. What happens when you have an additional variable? So of course, so it largely means that you will integrate one more time. That's it. Are you with me on this?
Yes, sir.
Yes.
Sir.
So this is the first part, right? So now you integrate with respect to x, what will happen? Tell me. So 1 upon yz log x. Okay. So that is 1 to e dy dz. 1 to e and 1 to e. Now you put the limits over here. 1 upon yz is here. So log e minus log 1. What will happen? 1 minus 0.
1.
Okay. So now 1 to e, again 1 upon yz, you take 1 upon z as constant, it becomes log y. 1 to e, you are left with dz. So again, this will becomes what? 1 to e. Okay. So 1 by z log 1 log e minus log 1 dz. So that's it. Log z 1 upon 1 to e, 1 is the answer. Are you with me on this?
Yes, sir.
Yes, sir.
So calculating these integral is pretty much easy. Okay. Is it fine? Yes?
Yes, sir.
Tell me.
Yes, sir.
Okay.
Yes, sir.
Now, let me move to a little more complicated, not that much, but the complicated, more complicated as far as if you compare it with question number 9. Okay. So that is question number 8. I've already done the 9. Yes, it's 8 now. So question number 8. So that is 0 to root 2, 0 to 3y, and x square plus 3y square to 8 minus x square minus y square. Yes, you're with me?
Yes, sir.
Yes, sir.
dz, dy, dx. Now it is clear that this is z. So these are the limits of z, right? This is y. So these are the limits of y, right? And sorry, it is slightly wrong. Yes, I wrote it wrong. Yes, so these are the limit of dx dy. So these are the limits of x. So these are the limits of x, and further these are the limits of y. These are the limits of y. You're with me? Tell me. Is it okay?
Yes, sir. Yes, sir.
Okay. So now, so integral of 1 would be what? Yes,
Z.
z. X square plus 3y square to 8 minus x square minus y square dx dy. Okay, is it fine? Yes, tell me.
Yes, sir.
So 0 to root 2, 0 to 3y. So this becomes 8 minus x square minus y square minus x square minus 3y square dx dy. Right? So take this to the next page. 0 to root 2, 0 to 3y, and this becomes 8 minus 2x square minus 4y square dx dy. Yeah, you with me?
Yes, sir.
Is it fine?
Yes.
Okay, so 0 to root 2. So integrate with respect to x, 8x minus 2x cubed by 3 minus 4xy square 0 to 3y dy. Yes. Is it fine? Tell me. Okay.
Yes, sir.
Yes, sir.
Okay. Okay. 0 to root 2. Now you put those things over here. 8 into 3y minus 2 into 3y whole cube by 3 minus 4x into 3y whole square. Sorry. 4 times the 3y into y square. Yes, minus 0 करेंगे तो क्या हो जाएगा? 0 ही हो जाएगा ना? You put x is equal to 0, all the expression will be 0, right? So we'll only put the upper limit. So 0 to root 2, 24y minus, this becomes what? 2 times the 9, 18y cube, right? Yes.
Yes, sir.
Yes, sir.
So now we are left with 24y minus 30y cube, 0 to root 2 dy. Now let's move to the next part. So this would be 24y square by 2 minus 30y4 by 4, 0 to root 2. Is it okay? So this becomes your 24 times 2 by 2, 30 times 4 by 4. Right? So our answer is minus 6. So volume would be 6. Now, can you tell me what is the difference between getting the volume from here and getting the volume from 2D? Can you tell me? Okay. Let's say, I'll tell you how. So let's pick this thing over here into the next page. Okay, so let's say जब हमारे पास 2D था, ओके, तो 2D था तो हम यहाँ पे एक नीचे बेस रहता था और हम ऐसे इसको we used to divide into the sub rectangles, and then we have a kind of surface over here, and then we used to get those pillars, and then we get the volume, right? You're with me? Tell me.
Yes, sir.
Okay, तो अब क्या करते थे हम? So we'll get all those pillars over here. Yes, and then again this, and then this thing. So this will be like volume bounded by this region, है ना? All those pillars. Is it okay? So this was ZFXY. Okay. Now, if you think of a 3D region of this kind, what happens? Try to focus. So let me first of all cut and then paste. I'll make it a bit small. Okay. Now think of this thing. Can you tell me what is the value of Z? Z is varying from where to where?
Sir, x square plus 3y square to 8 minus x square minus y square.
Yes. So this is a sort of situation when you have, let's say, this paraboloid, right? And we have another paraboloid, let's say this one. So basically, let's assume that you have two cups, right? And one is upward, one is downward. And you want to get the volume somewhere here. Okay? You're with me?
Yes, sir.
Yes, sir.
Okay. So, can you see the difference between this and this? Can you see? Can you see some difference? Getting the volume through this picture and then getting the volume through this picture. Can anybody point a difference?
तो सिमेट्री है एक में.
हाँ, इसी चीज को थोड़ा अच्छे से करके बोलो.
ये दो ग्राफ का मतलब
Then I'll let you know. Then tell me, is there any difference?
सर ये इंटरसेक्शन दो वॉल्यूम्स 3D फिगर्स का है और वो इंटरसेक्शन एक 3D और एक 2D का है.
और अच्छे से कर दो इसे, और अच्छे से कर दो. You are reaching towards the right point.
सर एक बिल्कुल प्लेन था, मतलब जो पहला वाला था उसमें एक प्लेन था और एक
Exactly. See, I tell you the main difference, right? So the main difference is here you used to get your Z in somewhat, in this sense that this is your Z, right? This height is your Z. Okay, right? So every time the starting point was from plane, right? So every time you used to start with Z is equal to 0, right? So somehow you can think that your Z was fixed, right? But here you see your Z is not fixed. Can you see this? Right? Can you see this? Your Z is not fixed.
Yes.
Yes, sir.
Why? Because your Z starts from here and ends at here. Starts from here and ends at here. Starts from here, ends at here. Starts from here and ends at here. So this is a sort of situation when your Z is also a kind of, height is also a kind of variable. That means it starts from here and ends at here. Is it okay?
Yes, sir.
Yes. Are you with me?
yes sir.
So this is the difference. However, the both are calculating the volume, right? But this is sort of, this is dealing with a sort of more complicated situation where the starting Z and the ending Z are changing. Okay, they are also depending upon the values of X and Y. Is it true? So here Z was not depending upon X and Y. Here used to be Z is always to be 0, right? Starting value. But here, if you see that the starting and ending both are depending upon X and Y because both are changing, right? As the X and Y are changing, the height keeps on changing. True? Yes, you got my point?
Yes, sir.
So basically, we have answered this question. What? Why to calculate the volume using triple integral? So that is one thing which we have answered. Now, let's try to answer one more complicated question, which I'm not going to answer it completely. You may go through the textbook and the other relevant sources. Now, my next question is, I know that this is, let's say, x is equal to y and b, and y, let's say, function of x, f1x to f2x, and the last integral, right? Let me, and the last integral, let's say z, which is some function of xy to some function of again xy, as we have, as we have dealt with this thing, okay? So, and there was something fxyz. What about this situation? If one is not there, if f of xyz is there, then what about this situation? What is the geometrical representation? What is the geometrical interpretation of this quantity? Can anybody tell me? Yes, anybody? You calculate to ho hi jayega, right? So calculating an integral is not a tough job. You can do it. But can anybody tell me what is the difference? I mean, what it represents really?
वॉल्यूम मतलब रीजन जिसका z इज
तुमने डेंसिटी का कॉन्सेप्ट सुना है? डेंसिटी?
Yes, sir.
हाँ, तो डेंसिटी किसके बराबर होती है?
डिपेंड करता है तो
मास पे
हाँ, generally what is that density?
Mass by
mass per unit volume.
Yes, so we know that our density is mass upon volume, right? So I'll say that rho is m upon v, right? Are you with me? Yes, tell me.
Yes, sir.
Yes, sir.
Okay, so now if let's say if I was in a double integral, right, and I was not taking the area, then this used to be my height function, and here dx and dy represents what? Tell me.
Length and breadth.
Yes, area.
Yes, sir. Area of rectangle.
Right, so area times the height means what?
Volume.
Volume.
Yes, so this was area, this was height over some region, and this becomes volume, right? Now come to this thing, come to the new picture, that means this thing, and here we have f of xyz over r. Of course, this r is now solid and this r is like plate, so dx dy dz. Now what is the dx dy dz? Tell me. Volume. Yes, and ये चीज अब क्या हो जाएगी? This would be density. This would be a density function, right? And volume times the density will become what?
Mass.
Mass. Yes. So getting these two together, this will become mass. Okay? Are you with me? Yes?
Yes, sir.
So I'm good.
Yes, sir.
Yes.
सर इसमें बेसिकली जो एफ एक्स वाई जेड है वो तो ऑलरेडी एक 3D फिगर है ही है, मतलब हम 3D फिगर का वॉल्यूम ले रहे हैं टोटली, मतलब देखा जाए तो
नहीं, हम 3D का वॉल्यूम नहीं ले रहे हैं. You are not. That's what I'm saying. See, ऐसे तो ये यहाँ पे हम dx dy की बात कर रहे हैं, तो dx dy क्या बना? सिर्फ एरिया. तो मैं यहाँ सिर्फ और सिर्फ रीजन की बात कर रहा हूँ जब वॉल्यूम बोल रहा हूँ, dx dy dz. मैं fx yz को इंक्लूड नहीं कर रहा हूँ.
ओके सर,
यू आर गेटिंग माय पॉइंट?
यस सर.
ठीक है, जैसे ये सोचो, ये एक्चुअली तो वॉल्यूम है ना, एक्चुअली तो ये वॉल्यूम है.
हाँ सर.
ये तीन चीजें मिला रहे तो वॉल्यूम है, तो ये दो चीजें क्या है, एरिया है, ठीक है। उसी तरह से ये तीन चीज ऑलरेडी क्या बन गई, वॉल्यूम,
यस सर, ठीक है,
राइट।
यस सर।
Yes. Anybody? Is it okay with you?
Yes, sir.
See, I'm spending more time on the concept than the questions itself. तो इसीलिए है कि तुम ज्यादा से ज्यादा अगर तुम्हारी अंडरस्टैंडिंग डेवलप होगी, you'll be able to do your question on your own and you'll find the things to be, find the things more interesting. Okay. So I guess we should stop here.